Start at sharp 6 o'clock, Rida. On my personal WhatsApp window. I'll be chatting you. See it.
Good evening, everyone. A very warm, energetic, and enthusiastic welcome to all our respected guests, mentors, coordinators, brilliant students, tech enthusiastic, and future defense innovators joining us live today. I am Rada Zareen, a student coordinator at KIYE Foundation, and it is my pleasure to host today's session of S Talks Lecture 11. On the behalf of ISRO Space Tutor and KIYE Foundation, I proudly welcome you all to the another power-packed, inspiring session, Lecture 11 of S Talks. I welcome you to the ultimate launchpad where textbook equations meet real-world defense systems, where students' curiosity meets national-level security and innovations, where young minds like yours begin their journey towards building a self-reliant, Atmanirbhar India. We are live on YouTube with the future innovators across the nations. Let's test the energy right now. Flood the live chat with your name and your college name. Let's see who is bringing the maximum power tonight. Wherever you are logging in from, remember that today we all are connected by one single powerful mission to learn, to innovate, to protect, and advance our nation through technology. And that is the true unstoppable spirit of S Talks. Before we bring out tonight's titan, make sure you don't make a single beat of this 52 journey. Take 5 seconds right now to hit the subscribe button on the YouTube while you're at it. Also check out our and join our WhatsApp channel and follow us on Instagram and LinkedIn. That is exactly where you get all the instant updates. Before we dive in today's mind-blowing topic, let's quickly remind ourselves what makes the S-Talk platform so incredibly special. The S in the S-Talk stands for Space, Aerospace, and Futuristic Technologies. The magnificent year-long initiative was created with a vision to spark a fire in students towards science, research, deep tech innovations, entrepreneurship, and next-generation engineers. Let's remember our core mission blueprint. 52 lectures, 52 speakers, 52 topics, 52 weeks of continuous inspiration. Every single Saturday, we gather right here to learn directly from the pioneers, the scientists, the defense experts, the researchers, and the visionary industry leaders who are actively shaping the technological shield of our nation. Because the future doesn't just happen, it belongs to those who learn, adapt, and innovate. And as always, our guiding anthem remains space and the futuristic tech are the next frontiers. Let's explore them together. Now, before we introduce our phenomenal guest speaker, let's make sure your keyboards are warmed up. Let's make this highly interactive. If you believe that Indian engineers and homegrown startups can build world-class tech to make our defense forces absolutely unbeatable, I want you to flood the chat box right now with Deep Tech India. Go ahead, type it out. Let's see those comments rolling. Phenomenal. That burning energy is exactly what drives true innovation. Never forget that every iconic tech founder, defense scientist, and entrepreneurs once sat exactly where you are sitting today as a curious student with dreams. Today's session might just be the spark that defines your future career in hardware, software, and defense systems. Now, to give you a deeper look into the driving force behind this entire ecosystem, let us take a quick look at a short audio-visual presentation showcasing the grand vision, ongoing achievements, and nationwide mission of the KIYE Foundation. I request our student coordinator to play the AV. Wow, that always gives me goosebumps. KIYE is truly not just an organization. It is a massive student led movement empowering thousands of youth with real knowledge, core leadership, and cutting edge opportunities. To share the real impact of this movement from students' lens, I would now like to invite one of our incredibly dedicated student coordinator, Ms. Sahasra, to share a glimpse of their journey and learning experience with the KIYE Foundation. Over to you, Ms. Sahasra.
Thank you, Rida, for this wonderful opportunity. Good evening, everyone. My name is Sahasha, and I feel extremely grateful to share my experience with KIYE Foundation. Being a part of this foundation has been a truly meaningful journey for me. Through the various programs and learning opportunities provided, I have gained not only academic knowledge but also important life skills such as communication, teamwork, confidence, and leadership. One of the things I appreciate most about KIY Foundation is the continuous support and encouragement given to the students. Our mentor, Satish Shetty sir and Naresh Indian sir, are always willing to guide us, answer our questions, and motivate us to achieve our goals. Their dedication has helped me believe in my abilities and work toward a better future. The foundation has also created a positive learning environment where students feel comfortable expressing their ideas and learning from one another. Many activities in KIY Foundation include Weekend Vibe up to K-6, where students got to show their ability in science and space fields. The exposure and opportunities provided by the KIY Foundation have encouraged me to think bigger and prepare myself for future challenges. I would like to sincerely thank the entire KIY Foundation team for their guidance and commitment to student development. Your support is making a real difference in the lives of many young people like me and helping us move forward to our dreams. Thank you. Jai Hind.
Thank you so much for sharing those wonderful words. Your growth and journey beautifully reflects the exact spirit of leadership and hands on learning that we want every student here to capture. Now, for the pinnacle moment you have been waiting for. Tonight, we are honored to introduce a true titan of Indian tech innovation, Dr. C.V.S. Kiran Garu. He's a distinguished aerospace technologist, an elite innovator, and the CEO and co-founder of the Red Balloon Aerospace. He is actively reshaping India's aviation and defense ecosystems, transforming complex aerospace design into tactical deployment ready national security assets. The Red Balloon Aerospace, a powerhouse dedicated to next generation aviation. Good evening, sir.
Good evening. Hi.
Good evening, sir. I'm the host Rida Zareem, a student coordinator at KIYE. Welcome to the S Talk series.
Thank you.
So
Thank
we'll
you.
begin your session just after a short intro.
Yeah. Just give me 30 seconds, okay?
Sure, sir. I'll
Give me 30
continue with
seconds.
the intro, sir.
Yeah, please.
Thank you, sir. Dr. C.V.S. Kirangaru is actively reshaping India's aviation and defense ecosystems, transforming complex aerospace design into tactical deployment ready national security assets. The Red Balloon Aerospace, a powerhouse dedicated to the next generation aviation, advanced unmanned aerial systems, and cutting edge deep tech solutions for the strategic sectors. Dr. CVS Kirangaru has successfully bridged elite industry R&D with a practical academia, engineering advanced aircraft system, and AI-driven defense mechanisms that safeguards our sky. He doesn't just predict the future of aerospace; he's actively building its shields. Drop those fire emojis in the chat. Put your hands together for the visionary himself, Dr. CVS Kirangaru. So, we are absolutely privileged to have you today with us. On the behalf of KIYE Foundation, ISRO Space Tutor, and the entire STOC community, we welcome you. The virtual stage is all yours, sir.
Thank you very much for the kind introduction. And, it's always nice to talk with young entrepreneurs, I would say. Not young researchers or young scientists, but I would say young entrepreneurs. Because as we grow our entire ecosystem, we want everyone to be entrepreneurs towards building a new India, right? So,
Definitely.
so good morning, everybody. It's always nice to be part of the, organizations who are trying to imbibe in a lot of scientific research into the minds of next generation. Yeah, so just as the foundation has introduced me, I am Dr. Kiran with very big name, and I did all my studies right from my bachelor's in India, then master's, PhD, postdoc, professorship in Germany, then continued my studies further on uh, into the field of materials. I always stayed in the field of materials. So when I started my career, I did my Bachelor of Technology from the Mahatma Gandhi Institute of Technology, Hyderabad, Gandipet. Yeah, it was in the field of metallurgy and materials. Always since my childhood, liked metallurgy a lot. Probably also driven through my mom a lot, because she used to work as a geochemist. And I was always amused by the rocks, the ores, what were present. And that led me take metallurgy. And I continued the field of metallurgy and material science throughout. After my bachelor's in India, during my bachelor's also, I did a lot of projects. I always am a passionate experimentalist. I used to do a lot of projects during my bachelor's as and when time was available. Yeah, approximately September, when everything is done, I moved to Germany to do my master's in the field of material science and engineering. I did my master's there, and during my master's also, I used to go and work at the labs. As I told you, experiments are very close to me. I worked in the field of nanocomposites. Composites are materials which are two phases in them. So I worked in those materials, nanocomposite thin films. Then, towards the end of my master's, I had the opportunity to work in the field of optical properties of nanocomposites, which are used in a variety of applications ranging from antibacterial properties to optical properties. Worked on quite good infrastructure which is available there. Then after my master's, I wanted to further go to do my PhD. So I approached the professor where I did my master thesis. He said there is a possibility for you to work on irradiation of nanocomposite materials. So I found the topic boring, to tell you frankly. But there was a small thing that it was a bilateral project between India and Germany, where I would be also having the opportunity to work both with India, keeping my roots of India very strong. So that was one of my prime motivation for that, doing my PhD in that field. But then the topic was also very interesting because no one had ever done such good studies, because infrastructure is very critical. And I learned a lot of advanced instruments during that course. I was also socially very active, like what all of you are doing, organizing events. I used to organize a lot of things. Already at that time, I was working socially as the president of the Indian Students Association. Also, we started a lot of activities, social activities. We did Indian festivals, celebrations, and everything. In the process, social thing is very important. So I also got to be elected as the member of the student government in Germany. It was an election which was conducted, and I was elected as the international student representative for the entire university. I was also elected at the student parliament. There's a student government of every university and the student parliament of every university. And that somehow led me to learn the language a lot. It just came. And that was my lot of social activities. During my term, I created a lot of new things, saying that world is open world, and created an event where all the student organizations come together under one roof and show their cultural things to the entire world. It was free for the students, and people enjoyed it a lot. All the embassies were invited, and then subsequently, somehow my social engagement went down because of increased technical aspects, and because of my overall activities. I was awarded the International Student Award during my PhD times, and then as soon as my PhD was done, I had the opportunity. I was looking for positions to do my further studies. Then a professor from the same university approached me, saying that would you be willing to do your postdoc with me? It's always nice, right? So I said, it was Professor Lawrence Kindler, and he asked me twice about whether I want to join his group as a first employee of the group. And I said, no, I don't want to join. I'm interested in staying with my own professor where I was doing my PhD. I like Professor Franz Hoppel, who was my PhD guide. It's called Dr. Father in Germany. PhD guide is treated equivalent to a father. And I really cherish the time what I had with him, or I love the time what I spend with him always, even today. And the whole process went on in such a way that when I told him that someone approached me, I don't know the professor, it's a new professor. He said, never do that. It's a good opportunity. You should take up new opportunities in life that will lead you to new heights. So with that point, I embarked onto the new journey with Professor Kindler, where I learned lots and lots of ethics. My entire ethics are, through Professor Kindler's activities, what I had interactions with him and everything. One of the most important thing which I would like to share is, when you as a researcher or you as a human being know something, try to share it. Try to make others learn. The moment you do that, you learn much more. The moment you stop doing it, you are half dead. So this was one of the greatest things what he told me. I never can forget it in my life. And then after working with him for almost, I think 2.5 3 years, I had very massive ideas in technology, and my ideas were becoming very, very cost intensive. Where a university said it's better you can go to better places. And I was just talking over phone with one of our collaborators at that time, one of my collaborator, my close friend, Professor Christian Kubel now. And then he said, why don't you come down when you're interested? We can have a chat. And I gave a presentation at the Karlsruhe Institute of Technology. It's called Forschungszentrum Karlsruhe. It's one of the most prestigious organizations in Germany, from the Helmholtz Association. And after the whole interview, or it was basically the presentation about myself, I felt very nice, because unknowingly I gave the entire presentation in German. And I was already fluent in German, and I like the group also. Very small group, a lot of excellent state-of-the-art infrastructure, which motivated me a lot more to work in the field of batteries, because I identified batteries as one of the very important field, batteries and cells. So I started working at Karlsruhe Institute of Technology, a center called Helmholtz Institute Ulm for Electrochemical Energy Storage. Thereon, I had deep thoughts of creating a very, very big infrastructure for electron microscopy in the country, in India, back. So I was building on plans because I saw Germany, and the Ernst Ruska Center in Germany is treated to be the mecca of electron microscopy. And I wanted that sort of an infrastructure to be available in India. And then I was constantly speaking with people that when we have such an infrastructure, at least nearby, it will be very good for the country. Yeah, and then I was always, from day one of going to Germany, always had thoughts of coming back to India. I used to say, I don't want to take up any permanent positions. So I always used to come back to the point of leaving Germany. And 2016 or so, I applied to DRDO, I applied to ISRO, and also to universities in India, the IITs in India. And immediately I got an opportunity to work at the Advanced Research Center International for Powder Metallurgy and New Materials in Hyderabad as a project scientist in the field of electron microscopy, and that too also electrochemical energy storage, batteries and cells. So I took up immediately the opportunity. It was also driven partly by, life, how it changes, some of the personal reasons also, health reasons. And as soon as I came back to India, it was superb, completely different, a shock, like a fish taken out of an aquarium and put into a different aquarium. And as soon as I joined ARCI, within 3 months, I got a call from ISRO asking me for an interview. It was simply superb to go to ISRO to give the presentation. And the moment I got through the interview under the leadership of Dr. Sivan, Dr. Sivan's last interview was with me. He took the interview for me last, before he became the chairman ISRO. And then I joined Vikram Sarabhai Space Center at Trivandrum. In the whole process, it was very nice. The amount of materials what are there in space is simply mind-blowing. So they were exploring all the unexplored regions. And basically, I used to look at atoms, what you all study in your physics in your 10th class. I literally look at the atoms, the arrangement of atoms, how the properties change with respect to the atoms. When you give a different type of stimuli to these, how they behave, that was my area of expertise. And I used to work on many materials as soon as I went into ISRO. It was super fascinating. Even today, I would love to, when time permits, look at electron microscopy. And then what happened, all of a sudden, we had COVID. And then during COVID, I was at Hyderabad, struck because of the sudden changes in the regulations. That motivated me a lot to come back also to Hyderabad. I applied also to some of the universities. There was an opportunity for me to work also with many other private companies. But irrespective of all these things, one major thing which happened during that time was the Honorable Prime Minister of India activities. The first point, it happened in 2020. So by 2020 May, this happened. Just before this, 2020 May, the Electron Microscopy Society of India bestowed me with the Excellence in Electron Microscopy Award for the entire country. The first award was, I think it was first or second award which was given to me. And in 2020 May, the Honorable Prime Minister announced this space to be done by private people, where SkyRoot was one of the premier organizations, and they performed fantastic tests at that time. Yeah, I really loved what SkyRoot used to do. And I also used to run a space news WhatsApp group when I was at ISRO, posting all the news which are going on globally. I was also doing a lot of literature study. I'm an expert of literature studies. So then I saw what SkyRoot did, and I was fascinated by that. went to Skyroot, spoke to Pawan when he was down with COVID, fully masked. And it was a fantastic conversation with him. We exchanged a lot of interesting ideas. And I took the bold decision, although it was difficult to convince my mom that I wanted to join Skyroot. And then I joined Skyroot in February as soon as I came out of ISRO. In the meanwhile, Skyroot's progress has been tremendous. Background work, what they were doing in R&D, and it was fantastic. Where I was part of the founding team with Pawan and Bharat, and I also had one new person in my life, which was Sirish. In addition to Pawan and Bharat, we were part of the founding team, sort of a close-knit team. Pawan, Bharat, Sirish, and myself. It was super fun working during COVID times. And then as soon as it all started, it was a race what we were running. The most important thing which I can never forget in my life was the launch of Vikram S, India's first suborbital mission, private sector. Yeah, it was only goosebumps come to me even when I talk about it. Yeah, so the entire team was working super hard. Yeah, respect to the entire team which brought the entire success to the country. Yeah, 18th November 2022 was a historic moment. And then after that, we were working with a lot of, both me and Sirish were part of the business team. We were also working with external people, collaborations, R&D institutes, all the universities throughout the country. Approximately 2025 regime, a lot of people used to come. They wanted to launch their satellites into space by using Skyroot's launch vehicles. We were, taking their payloads. We were helping them to evaluate them. And one of the most important point in the whole course was to, test these things. Space is something which is ruthless. So what happens in such a scenario is that if a satellite or if anyone who goes there cries for help, there's no one to save. So that's one of the most important reason why people say, yeah, we should, when we send something to space, it has to be 100% functional. So there should be no chance of anything which might work that shouldn't come. So ISRO has been very good in doing all these things in that way. So the same thing also repeats at any space organization. And the satellites used to be ground tested. The payloads used to be ground tested. A lot of vibration shock analysis, thermo-vacuum analysis, and tests and so on. But some of the experienced people from abroad always used to ask for high altitude. To one of the most prestigious organization in the country called the Tata Institute of Fundamental Research, balloon facility in Hyderabad, which has been started originally by Homi Bhabha. Homi Bhabha is considered to be the father of lighter than air technology in the country. And we used to send all the, people to TAFR, balloon facility. And what we have observed is it has been becoming difficult to get access to them because the amount of support what they could give for private companies from abroad was difficult for TAFR also. So at that point, we were looking at possibilities of a foreign or any other private company in the country which could do that. And to our astonishment, both me and Sirish couldn't find anyone. So we said, what is it so difficult or so? And then we tried to analyze the business model of it. And we found a very huge potential of creating an organization which is a unicorn, which could be having a potential of a unicorn in the coming years, both from a technical standpoint as well as from the point of a business potential. And that's how we created the organization called Red Balloon Aerospace. The initial thoughts came up approximately February, March of 2025. By the time we did all the analysis, the homework is very mandatory for any of these things in life. So Sirish and me were convinced that we should start it. And by May, we conveyed the same message to Pawan and Bharat, who are the founders of Skyroot. And then they embraced it with joy on one side and sadness on the other side because of, losing us. But that other side, Pawan and Bharat are always used to encourage entrepreneurs. In fact, we are like the third startup who has come out of Skyroot. And what happened was we started Red Balloon Aerospace in May. And by the time we could, we were a lot involved in many activities. We ourselves couldn't come out from our hearts just leaving Skyroot like that. So it took us some time to hand over everything in proper form to them. So by November, we were able to come and run the activities of Red Balloon. So at Red Balloon, what we are trying to do are like we build the different types of infrastructure, especially for the purpose of lighter than air platforms. So a variety of applications exist for that, and among all of them, the most important point is there is no limit for imagination. So that is one of the important point what I should say. And I will try to share some of the slides with you right now. So can you see my screen?
No, sir.
How about now?
Yes, sir.
So I'm just giving you a brief overview of what we do at Red Balloon Aerospace. So see, even now the name Skyroot always comes into my mouth. So this is a brief, introduction what we are trying to solve. So when you look at different layers of the atmosphere, what we study typically in our, day-to-day schooling, the drones, which are very, very low, they operate at very low altitudes. Then we have the helicopters, then we have the aeroplanes, and then we have the fighter jets. And then when we go into the thermosphere, we have the launch vehicle companies which operate. We have the communication satellite companies. We have Earth observation companies. We have companies like which help us get some valuable information from the data what we do. But there is a layer of atmosphere between the thermosphere and the troposphere. That's the mesosphere and the stratosphere, which is completely unused or underutilized for atmospheric layer, where TIFR operates in India as a ballooning facility, one of its kind. And many other organizations also do work in that regime, like ADRD, DRDO lab, and some of the atmospheric research facilities. In addition, globally, there are many companies working in that regime. So what we are trying to do is we're trying to bridge the gap between the thermosphere and the troposphere, especially in the stratospheric regime, where internal combustion engines don't work, and mesosphere is completely brutal in nature. So at these altitudes of stratosphere, the pressure and temperatures vary in a very, very different way, which leads to the fact that specialized materials are needed for working in this regime. So what we offer from Red Balloon are different types of platforms. One are high altitude super pressure balloons. So these balloons have the capability to stay in near space for longer amount of times. And then we have second type of products which are called aerostats. Aerostats are systems which are tethered to the ground, where the power and communication to these lighter than air platforms goes through the tethers which are there. And then our ultimate product is the airship, which is called Helix. So all these systems operate on modular architecture and are capable of variety of applications, ranging from scientific data collection to Earth observation, remote communications, GPS. They can be used for launching rockets. They can be used for space technology test beds, near space travel, mineral mapping. telecom, earth observation, cargo transportation, passenger transportation. And now imagination is the limit, what I could say. Everything what satellites could do could also be done by using the lighter than air platforms, especially with an additional concept of reusability, that all the payloads or all the satellites which are being used by these are reusable. And also one more thing is that they are persistent in nature. That means you can monitor one particular region, or you can cater to one particular region continuously. So this is what are the various applications. Some of them are listed on this slide. So among all of these things, we need good team. So we have some people on the team who are helping us. So Sirish and myself founded Red Balloon. And then we have Mr. Srinivasan, who's an expert in the field of ballooning. And then we have Mr. Anand, who is also an expert. Both of them were heading TAFR for a good amount of time. Then we have Dr. Kavya, who's also our honorary advisors. It always becomes important for people from various fields to help us and advise us when we're starting such an organization. And then we have Colonel Jitendra. Colonel Jitendra formerly was from the Defense Space Agency, and then he's currently with XG Links. And then we have Mr. Ram, who's a successful entrepreneur. Rajesh is the CEO of ArcelorMittal in Duisburg in Germany. So a variety of people come from various backgrounds, helping to shape our products and also the entire ecosystem or the infrastructure what we are building. So what we are trying to build are the cell towers in sky. So basically, whatever satellites offer, communications are possible to be offered also by airships. The only advantage with airships is that the latency is very good, and also the data rates are very good. So an airship typically can work as a cell tower in sky by stationarily being positioned at one position, or it could also do earth observation and also do connectivity for flights or any flying objects. It could be used, for example, the Bharati Antariksh Station and Gaganyaan missions of ISRO are happening, right? So we could take the crew modules to an altitude, whatever is predetermined, and we could do all the drop tests, because re-entry is very important because it involves humans. And we could also use it for launching launch vehicles. If you consider a launch vehicle, typically a class of launch vehicle like the small satellite launch vehicle of ISRO, or the Vikram 1 of Skyroot, or the Agniban of Agnikul. All these launch vehicles are small satellite launch vehicles which have the different stages in them. If you remove the first stage of the launch vehicle, that is typically used only to go over into the stratospheric regime. So if you remove the first stage and take the entire rest of the rocket to stratosphere and launch it from there, you save significant amount of fuel and also the significant amount of weight of the launch vehicle, which runs into very good economics. And of course, all of us are fascinated by tourism. So all of us want to go on holidays. So now this is the era of Gen Z where people want to go into space for tourism. So we'll also be catering to the needs of the near space tourism activities. So with all these things, we started the Red Balloon, and we created a small R&D unit inside a university campus called Mallareddy University Campus, which was supported in the initial stages in a very, very nice way. And then we created a small infrastructure, not a small infrastructure, a quite big one. And then the entire infrastructure was made available. So what you see are some of the images of the infrastructure what we have taken. And we did different tests for the lighter than air platforms. These are all super pressure balloons. The super pressure balloons have the capability to stay in near space for longer amount of times. That means probably from months together, compared to the zero pressure balloons, which India has been doing it. And we did a lot of tests on these super pressure balloon platforms. And finally, we were also on the news for doing all these tests. On May 27th, India launched the first super pressure balloon of the country, where we joined the allied countries who have the capability of super pressure balloons from in the world. And yeah, so this is a small video about I think video will not play properly, so you can actually have a look at the video on YouTube. So let me stop over here in that case. So through these on 27th of May this year, we did the first super pressure balloon launch of the country, carrying customer payloads in addition to our own experimental payloads, and created the entire ecosystem for lighter than air platform. And what we are trying to do is we are trying to get the entire infrastructure of stratosphere from India for the world. So what happens in this is that India also owns the entire layer of infrastructure. There, we cleared the platforms, agnostic of the type of application what we are into. So, yeah, with this, I think let's try to take some more questions from the audience. And I would say thank you for the kind invitation. It's always great to speak to young minds.
That's truly incredible and amazing, sir. Thank you so much, Dr. Kiran Garu, for completely redefining how we view deep tech and national sovereignty. You have ignited a massive spark tonight. Audience, it's the time for your high-octane interactive Q&A. If you have burning questions on space ventures, unmanned systems, or breaking into strategic defense tech, drop them in the YouTube live chat right now. Keep them sharp, keep them curious. Sir, we have fascinating questions from the audience. With your permission, should I proceed?
Please, please.
What stimulation tools and testing processes does your team use before deployment?
Oh, there are a lot of simulation tools what we use. We create some of the tools ourselves. We have proprietary software what we have made over the last few months. And these are the tools what we are using for prediction of how the balloon, progresses when it goes from one altitude to the other altitude. We also are able to track how it goes. Some of the tools are available online, which we use. We also created a lot of machines. The balloon, when you look at a balloon or any of the lighter than air platforms, they don't have inherently the load bearing capacity. So what happens is we need to also devise the structures around in such a way that they bear the load. So how much load, how much of these things, basically the principles of buoyancy, how much hydrogen needs to be filled or how much helium needs to be filled to get to one particular altitude which the customer wants, all of these things change with respect. And we have our own built tools now, so which we use them now.
Thank you, sir. Moving on to the next question. How important is research experience for students entering the aerospace industry?
Of course, every time it's very important. So I'll tell you one example from my life. So when we started Red Balloon, the initial point when Sirish said, it's very nice from the business perspective. What about from the research perspective, technology perspective? How do you do that? So to my, happiness, I can tell you, I worked on similar materials, nanocomposites in Germany. And because of my work in that field, I was able to directly translate that research into application. The first time in my entire life, I'm really honored to say that I was successful in translating the research into actual application. It always helps when you do research, and that too at not one particular unit. You do it at multiple places. So what happens is that you diversify your channel into a wide area rather than narrowing down your thoughts. So it's very important. So try to do as many projects as possible. During my bachelor's, when I was studying at MGIT, I used to do projects every month wherever there is a possibility. Even I was very proficient also in computers and software. So during evening times, as soon as the college used to finish, from 5 o'clock approximately until 8, 9, 10, I used to go to computer classes. And people thought I would shift my branch into computer science, but I always used computer science. Even today, I use computer science to the maximum level. If someone says it's not possible, for me, everything is possible. Only difficult things are rockets and some parts of rockets.
Truly, sir, that's incredible. The chat box is completely frying with excitement, sir. Here's the next great question, one from the students. With the rapid growth of Indian private space sector, what specific technical skills, software tools, and project experience should aerospace students focus on today to become industry ready?
One of the most important point to be industry ready is more than the software skills, your basics.
Mm-hmm.
Your fundamentals should be strong. ChatGPT, AI tools cannot get your fundamentals strong. You have to do your core studies. Utilize AI tools to the best possible extent. It's something like a new language what you're learning. If you know the national language of a country, it's like a added tool for you. I just talked to you in German now. Ich kann die ganze Vortrag auf Deutsch unterhalten.
That's
So,
completely understandable when we see.
so the point is, it's like a tool. You should consider those things as a tool, and there should be never a full stop. The process of learning is comma, and the moment you stop that passion, as Pawan and me always say, that passion should be there, that spark should be there, and that should lead into obsession, and it should never be a comma. It should never be a full stop. It should only be a comma.
That's amazing, sir. The next question for you is, how does the population system selection affect the mission performance and payload capacity?
Can you repeat the question? How
How
does that?
does the propulsion system selection affect mission performance and payload capacity?
Of course, these are not only two parameters which are related. If you're talking about launch vehicles, or if you're talking about balloons, or any of the airships, all of these things have many, many more finer parameters. So it's not only these parameters which actually have an effect. There are many more parameters which are directly and indirectly affecting. That's a separate thing which are technically, it will take longer time to explain.
Thank you, sir. Sir, before we move on, we have our incredibly dedicated student coordinator who wants to interact and have a personal Q&A. With your permission.
Yeah, please.
Hi, sir. Good evening.
Good evening.
Sir, I'm Hasini, a first year student with big dreams, limited experience, came for your guidance. What would be one thing you ask them to do consistently for the next 4 years, sir?
Learn, learn, learn. Topic A, relevant to you. Topic B, not relevant to you, but still learn. Topic C, not at all relevant to you, but still learn. Widen your field, never narrow it. The moment you do that, you have acceptance in all fields. At a bachelor's level, at a master's, the higher you go, it becomes more and more difficult for you to become broader. You only keep on going narrower. The more exposure you have to various fields, various topics, that is what is the success in life. And remember one thing, never ever in life there is only a product is built only by one field. It's always confluence of all fields, be it either engineering or all sciences. Everything should come together to build one product. Nothing is built only by one thing. So you never think you only can do everything. You always need an entire plethora of fields coming together. Okay, that's what is my
Thank you, sir. Thank
point to
you so
everyone.
much, sir, for your guidance.
Thank you.
Our next exciting questions from the students. What message would you give to the young minds who feels aerospace is too complex or out of reach?
Nothing is complex in life. Remember, nothing is complex in life. Nothing is difficult. It's only the perception of the mind. The more complex things you take up at this level, you can create new things in life. That is very important in life. Especially, for example, you might be having brilliant ideas now. You have to open up and ask questions. I might not be able to answer all your questions, but you have to ask questions. If the moment you don't start asking questions, nothing goes. But at the same time, remember, if you have any nice ideas, implement them. Implement them, because at this point where you are, that is in your bachelor's level or master's level, if you do a mistake, there are someone who can back you up. Your teachers can scold. Maximum, they will scold. You start a company, you fail, nothing happens. But as you grow much higher in career, in life, failures can never be accepted so easily. Now, they are acceptable. But the chance of getting it successful are also equally high, because all the students have out of the box thinking. Think out of the box, create solutions, make your life easy as well as life of everyone easy.
Truly, sir. Next question for you is, how do you optimize the trade off between payload capacity, flight duration, and operational cost?
Everyone want operational cost to be as minimum as possible. The customers always want it. The next important point is there are also payload costs. What are the other factors? Whatever you said, what are those?
Payload capacity, flight duration, and operational cost.
Flight duration is typically given by the customer. Yeah, payload capacity. If we have two different concepts at Red Balloon, what we are trying to do is we are trying to do ride share missions where multiple people come up with individual payloads. They just snap it into our system, and we provide power, we provide communication to them. So that is one way of utilizing the effective payload capacity. And then secondly, we also have dedicated missions. For example, the student says, I want to have the entire thing for myself. We also have that such sort of a system. So that is the way in which we take care of the payload capacity. We have payload capacities as low as 50 kilograms of payload capacity to as high as 25 tons of payload capacity to near space. So depending on the customer needs, we adjust the size of the balloons, which range from as small as 30 meters or 10 meters to as big as 300, 400 meters. So effectively, you can think half of Burj Khalifa.
That's quite huge.
Yeah, indeed.
So, to end this exciting interactive section, one last question for you. What technology breakthrough do you believe in currently, underestimated, but could completely transform the aerospace industry within the next 10 years?
So that's what I'm working on. So what we are trying to do is try to utilize the entire underutilized atmospheric layer of stratosphere. We strongly believe in the fact that we could create a very good commercial activity in that. We could ease lives of people at fractional cost, at that too very, very economical. And just imagine a scenario where your mobile communications or your internet is not there for a few minutes. It's very dangerous to even think about it, right? So that's what we believe in creating. We want to create the entire layer of infrastructure where ease of life for everyone happens. For example, a vehicle going through another vehicle which is there, both of them talk to each other through network communications. So that's what we are trying to create, a very high latency. And we are trying to get to the point of non-terrestrial networks and 6G communication in the country, which will be useful for the next generation, especially with a lot of IoT devices all of the people are making. It needs communication direct to device. So that's what we believe very strongly can be achieved by Red Balloon Aerospace, and we strongly are working towards that.
That's amazing, sir.
Thank you.
That's incredibly clear and profound explanation, sir. Thank you so much for simplifying that concepts for us. You have given our future engineers a complete roadmap, I believe.
Thank you.
As we draw the curtains on this spectacular evening, I would now love to invite our student coordinator, Miss Neha, to deliver the formal vote of thanks. Miss Neha, over to you.
Thank you, Rita. Good evening, everyone. I'm Sneha, student coordinator of KIYE Foundation, and it is my privilege to deliver the vote of thanks for today's STOCKS Lecture 11. On behalf of entire KIYE Foundation,
I would like to express heartfelt gratitude to our honorable speaker, Dr. C.V.S.KIRAN sir. Thank you, sir, for sharing valuable insights and experiences with us. Your words have inspired us to think bigger, learn continuously, and explore opportunities in the aerospace sector, sir. I'm sure your journey and ideas truly motivated everyone watching this session today, sir. I would also like to sincerely thank our Chief Mentor, G. Satish Reddy, sir, all the coordinators, volunteers, and participants for making this session engaging and successful. Your presence and active participation added great value to today's session. For many more inspiring sessions, opportunities, and updates in the future, we request everyone to stay connected with KIYE Foundation by subscribing to our YouTube channel, follow us on Instagram, and join our WhatsApp channel. Once again, thank you, sir. Thank you so much for joining us today and making this lecture truly memorable with your inspiring words and valuable guidance. Thank you, everyone. Have a great day ahead. Jai Hind.
Yeah.
Thank you
Have a
so
nice
much for those beautifully articulated and heartfelt words of gratitude. What an absolute masterclass in national pride and purposeful engineering. A massive thank you to Dr. C.V.S. Kiran Garu for his invaluable time, to our technical crew behind the scenes, and finally to our magnificent audience, the future engineers and the innovators of India. Never stop questioning, never stop building, never stop dreaming fearlessly, because the technological sovereignty of our nation lies in your hand. And always remember a unified mission: 52 lectures, 52 speakers, 52 topics, one single unstoppable mission: empowering the future innovators of India. Before you sign off, subscribe to the channel and hit the notification bells right now. Follow the KIYE Foundation on the LinkedIn and Instagram, and also turn on the notification for the WhatsApp channel as well. Thank you so much, everyone. Have an absolute wonderful weekend ahead. Jai Hind.
Yeah.
Thank you, sir, for your valuable time.